March 20th, 2004, Redis publishes this blog post announcing the shift from BSD to SSPL. Did you know about this before I did, or was like the blog post the first thing you had sort of heard about it, or like how did that come down for you?
So they had told us about 24 hours in advance, just sort of as like a heads up, by the way. But no, yeah, we were basically learning about it at the same time that everyone else learned about it.
Okay, so then how quickly did the fork come together and deciding, hey, we're gonna do some sort of fork? What was that timeline like?
So I think I have these dates right. So it happened on March 20th. We had basically decided we were going to fork on March 22nd.
When was the first Valkey release?
So April 16th was when we launched the fork.
And now, of course, we have some new developments just in the last week now, exactly a week ago. Redis announces they're sort of back to an open source license, AGPL. I guess, like, does this change anything for you and Valkey, or how do you think about that? What's up, everybody? This is Alex, and I'm super excited to have Madelyn Olson on the show today. She is a principal engineer at AWS, and she's like one of the big people in the caching community. She was core maintainer for Redis for a long time. I think the person a lot of people thought of for that. She also was like one of the co-founders of Valkey after the Redis license change. So we talk about her background. We talk about the Redis license change and sort of how she found out, what happened, how to get to Valkey. And then just a lot of time on just like performance improvement stuff in Valkey and what that's like working with that. And it's just really interesting, I think, to go deep with someone like that technical, able to explain like these low level things that I have no experience with. So it was really cool there. She also got a really good story about using AI at the end that was interesting and unique. And I hadn't heard that one before. So check that out. If you have any questions, if you have any people you want on the show or comments, anything like that, feel free to reach out to me or Sean. And with that, let's get to the show. Madelyn, welcome to the show.
Thanks for having me.
Yeah, I am very excited to have you on. You are a principal engineer at AWS, and I think more famously, you are like a former core maintainer of Redis. You're one of the creators, founders, I don't know how we say that, of Valkey. And just like, as I've gotten more into the caching world the last couple of years, your name is like the one that always comes up about people. I think you've been mentioned on this show by Roman from Dragonfly, from Quaja at Memento, and just like, yeah, a lot of people speak really highly of you. So I'm excited to have you on. I guess for people that don't know as much about you, can you give us a little bit of your background?
Yeah. So yeah, my name is Madelyn. I'm a principal engineer at Amazon. Within AWS, I work primarily on the Amazon Elasticache and Amazon MemoryDB teams. I've actually only worked there. I'm one of the few Amazonians who I joined the team and have worked there for over a decade now. I can actually say that I've worked on the same team for 10 years. So early on, I was always a big open source proponent. So within a couple of years, I started contributing a lot to Redis open source. So we were the managed in-memory database team. So we managed Memcache and Redis for a long time. So I advocated a lot to, take all those things that we were sort of putting into our internal forks of these projects and sort of pushing them upstream. The thing I was most well known for was pushing a lot for TLS within Redis. Redis was very resistant to accepting it for a long time, but after a bunch of iterations, we figured out how to make that happen. And so for that work and other work, when Redis moved to an open governance model in 2020, I got asked to become one of the maintainers for the project. So that was sort of my big involvement. So I was an open source Redis maintainer for 4 years. Redis, very notably, moved away from an open source license in 2024. And so that led me and some of my other contributors from the open source Redis project to make Valkey. And that's what I've been working on for the last year or so. So yes, co-creator, co-founder. Co-founder sounds a little pretentious. Co-creator sounds better.
Yeah. How do you talk about something that's like an open source project that's within a foundation? I don't know how to talk about that, but whatever. You are one of the impeti behind the project.
Yeah, I'm very friendly. So I tend to be the face of a lot of things, but I always feel bad because I don't write the most code. Like there's other really smart people in the project and I want to highlight them more, but they're engineers.
But also like that like explanation piece and just like sharing and marketing type piece is super, like not marketing, but like just like, making other people aware of it. I remember watching your reInvent talk. I think it was 2020. Is that when you did like the Elasticache maybe performance? Mm-hmm. Yeah, that was the first time I heard of you and I was like, wow, this is a great talk. And then I just like see your name popping up all over the place. since then. And I think that's just like a really important role to like make people aware of all these things. So, you mentioned you've been at Elasticache for 10 years. Was that like your first job out of like, did you have other jobs too? Or did you like, was that your first one?
No, the that was my first job out of college. It was I was actually an electrical engineer. I had started getting involved in databases through some like research I was doing in undergrad, and I got very kind of involved in like hacking with Postgres because like it wasn't meeting my analytic needs at the time. We were trying to do analysis of like email. We're trying to build like passive radar systems, and we had this huge amount of data. And we're trying to like hack Postgres, and so it was like hacking in um, like transformers and stuff into Postgres. And then basically I got an offer from Amazon to work at DynamoDB at the time.
There you go.
And then I joined. And it's like, oh no, actually you're working on this small other NoSQL service called Elasticache. I was like, oh, okay. And so, yeah, I've just been doing that for 10 years. It was kind of not what I was expecting.
Yeah. Yeah. And like, were you like a low level performance expert? Like, were you like interested in that sort of stuff? I mean, like, I guess how did that come about?
Sort of, yeah. My actual pathway. So again, I was an electrical engineer. So all of my coding came from those like programming competitions, like the GPC one, the Google one, and then like there's this thing called Project Euler, which is like more of like a math heavy programming competition thing. And so that was my entrance. So like I was actually very good at low level optimizations. Like I had written assembly code um, quite often to optimize stuff. I actually was really good at x86, like actually knowing the instruction set when I joined Amazon. And I was basically asked to write a bunch of Java code at the time, which was fine. It was okay. But no, yeah, it's kind of like one of those things where I think the traditional CS pathway doesn't do a lot of that very low level software engineering stuff. And then also I had taken like computer architecture classes, which is also not like most CS take like introduction to computer architecture, but I had taken like high level. I had taken like a 500 level, like a master's level computer engineering class by the time I joined Amazon. So that also helped a lot with this type of programming specifically. Because like if you're writing mostly in JavaScript, you really just care about algorithms. You really don't care about like, the memory layout of the data formats.
That's totally true. Like, I think this caching stuff is so interesting, and I try to read like the Valkey release notes or like some of the papers, and it's like it's way harder for me even than like database type stuff because it's like dealing directly with the memory and like it's so close to the metal where I'm like, man, I just have no context for understanding some of this stuff, which makes it super interesting, but also like hard to understand all that stuff, how it works. Okay, so you mentioned. One of your like early things was convincing them to add TLS to Redis core. I guess like why did they resist it for a while? What's the story there?
So yeah, so Amazon Elasticache wanted to build TLS because a lot of our customers wanted it for compliance reasons. So it's big for like FedRAMP, HIPAA compliance. But if you sort of think about what Redis is, it's a hash map attached to a TCP server. So adding TLS is actually extremely heavy overhead, right? In the early days, before like the Graviton instances have kind of done a good job of optimizing that a bit, and like modern Intel hardware is pretty good at optimizing the crypto involved, it was somewhere around like 30 to 40% CPU hit. So if you were bottlenecked on basically like the requests per second that the cache could do, you would be paying twice as much to enable TLS. So it's a very big impactful problem. And basically, the goal at the time of Redis was to keep things simple. So changing the paradigm so that, we had like, it was actually very intrusive to like the connect, like the networking layer. So what everyone was using at the time was basically a TLS proxy in front of Redis. So they terminate the TLS at the proxy layer and then send TCP to Redis. But as like how we just talked about, all Redis is like a TCP server plus a hash map. And so you're basically adding another TCP server. And so we were like, this was like the dogma at the time. It's like use TLS proxies. And it's just like, it was really expensive. So like, well, this needs to be in this engine. Like it needs to be, natively there. You don't want to pay this double cost. So we had built this inside Elasticache, and it was sort of like the first big change inside our internal fork within AWS. And we were finally starting to, pay the cost. Like, we wanted to stay compatible with open source Redis, but we also wanted to have this code. And so it was very difficult. So like we were very motivated to get this code out of our internal fork into open source. And so we were prototyping a lot. So basically, there's like three main stages of us pushing this code to open source. So the first was like, hey, let's just dump what we have. And we got sort of the pushback that it was kind of too complicated. So we tried to refactor it a bit into like sort of like a pseudo proxy where we were able to like reduce some of the overhead and like kind of build the proxy into one process. But then we saw like, it was using 160% more CPU than it was if we just did it normally. And so we finally sort of were able to take some of the learnings of that prototype and sort of build a new implementation that actually is what kind of got finalized in this abstraction layer. So we have this like connection abstraction, which kind of abstracts away the TLS part. So it still kind of looks like TCP, but can also support TLS. So, it's that sort of like iterative approach that like finally got us to get it accepted in open source. And I really like the story. Like I can go into a little more detail, but it wasn't just AWS. It was AWS and Redis sort of working together to sort of figure out like what's the right thing for the project. And that's always what I think is like the most important thing kind of to build like the right thing for open source projects. Like you see a lot like single vendor projects, they're like, we're doing it the way we want to do it. And they don't really take into account what like the community really wants.
Yep. Interesting. And so timeline, was like 2018, 2019? Is that when?
That was 2018 through 2020. It took 2 years.
2 years to get that. Okay. Wow.
It was a little hard because like when I started contributing, it was really just Salvatore. Like he was the main contributor to the project. There were some other folks as well. But there was no I one of the big contributions I made to the project was I created a Slack channel for us all to talk to more online. We had like online syncs. They weren't videos, like, it was like every like once a month on Wednesday, we all got on the Slack together and asked Salvatore questions. And so we talked a lot about TLS and like so.
And was that replacing like email lists or like GitHub issues or like what was going on before that?
I think that was mostly replacing. Yeah, I was trying to get because GitHub issues are very low density. You have to type a lot. And so I was trying to replace that with more high density communication. People didn't want to use video at the time, but actually maybe Slack might not have supported at the time. I don't remember. This is like pre-Zoom. This is like pre-pandemic. So I think it was a little weird.
Yeah, for sure. I remember Slack bought that one company and integrated their video for a while. And then it's definitely not their video implementation, but for a while they had some other goofy video provider in there. So maybe it's that.
Yeah. So.
Yep. Okay. And then so at some point you became a core maintainer. When did that happen?
So that was in 2020. So Salvatore stepped down in July of 2020, right? Because this is 3 months after the pandemic started. So it was like kind of weird time-wise. It's like sort of surreal. So he stepped down. So Redis went from a BDFL, a single benevolent dictator for life, to a core team. So the core team was still facilitated by the company Redis. And so they had three folks from Redis, the company, then me and an engineer from Alibaba named Xiao. So we were like the core team. So we made decisions on what we called major decisions for like any API changes. Like that went through this little core team. So we met up and we decided kind of what was like the direction of the project.
Yeah, gotcha. And is your work like primarily like Redis, now Valkey core, like data plane type stuff? Did you work on any like control plane type stuff for Elasticache or any of that sort of like you work on all of that too?
Well, so not anymore. So now I just work on open source Valkey. So I've kind of ebbed and flowed about like kind of what I'm working on. Like at the end of the day, Amazon wants me to produce value for the company. So like, what's best? Well, no, I shouldn't say that. I should say it wants me to work on what's best for our customers, right? So most of the time, in the last couple of years, the best use of my time for our customers is to deliver software open source. But early on, like we didn't really do much in open source. One of the first very big project I did, that was part of the Rolling Stone, the migration from off of Oracle. So there's a big initiative within Amazon to move from Oracle to a lot of it to Dynamo, some of it to Redshift, some of it to other databases. So I was the one that migrated our Oracle database for our service to Postgres, which was
interesting,
a fun thing to do. Yeah.
Yep. Yeah, I've heard a lot of Rolling Stone over the years. So, that's fun.
So I've done that stuff.
I
I also built some like other features as well. But like the big thing, like, have done was like I own version currency. So I was the one responsible for making sure our internal version was compatible with open source.
How hard is that? Like maintaining this fork? Yeah, I guess like is that like a total headache, or is that like pretty manageable to do something like that? I mean, that just seems like a big job.
It is a big job. It takes us a good bit of time. You can kind of see in how much time it takes for Amazon Elasticache to launch a version compared to when it was launched in open source. You can kind of see that lag there. Um, and it's something I would like to see us do better at over time. Because a lot of it's because we've built stuff that really should just be open source. Like there's some very big things we've built. Like in the managed service, we have a feature called like data tiering. So we can spill data from in-memory onto SSDs and pull it back in all transparently to the end user. So that's like one feature we have that, maybe we'd like to open source it, but how are we going to open source it? How does it work? It's very finely, configured for the Elasticache service. But there's other stuff we've kind of talked about that it's like, yeah, we should just open source it, right? Like the performance stuff that we pushed into Valkey 8 was all stuff we had built internally. And we're like, we don't need this to just be internal. This should just be an open source. And we don't want to deal with having to deal with merge conflicts. So we just shoved it all into open source.
Yep, gotcha. So has that gotten easier with like, I guess y'all still offer Redis somewhat. And then there's, I guess like, has that gotten easier with Valkey of just like, hey, there's a smaller divergent between like the fork and the open source one?
I would really like to say yes, but at the same time, we're delivering features for our customers at a high rate. And so sometimes there's this big internal conversation we have, which is do we upstream something first or do we upstream it later? So do we build something primarily in the open source, then merge it back, or do we build it in our internal fork and then figure out ways to push it to upstream later? And like the main difference is just time to market, right? We can build something internally much faster and push it upstream, but that's not always, and sometimes that meets, requirements, and there's a lot of internal politics that just, happens at all companies. And so we're constantly having this conversation. So we're and that was the status quo, right? Status quo 10 years ago, we always built something internal first and then we upstreamed it. So it's sort of this it's been like this 10-year kind of slowly shifting more towards upstream first.
Yeah, that's nice. Yeah.
So one day I think we'll get there, but.
Yeah, cool. Okay, I want to talk a little bit about the license change just for some background before we get into Valkey performance stuff. So I guess first of all, just walk me through this. Like March 20th, 2004, Redis publishes this blog post announcing the shift from BSD to SSPL. Did you know about this before I did, or was like the blog post the first thing you had sort of heard about it, or like how did that come down for you?
Yeah, so they had told us about 24 hours in advance, just sort of as like a heads up, by the way. But no, yeah, we were basically learning about it at the same time that everyone else learned about it. And so, yeah, they moved from BSD license to a dual license SSPL and RSL, which are two proprietary licenses. And at the same time, that like I think that's like the thing that most people notice, but at the same time, they also dissolved the open governance that we were talking about before, which you kind of have to do if you're just going to unilaterally change the license. And then they also added a CLA at the same time, so that when you contribute, you also have to sign basically allowing them to take your contribution and relicense it.
Gotcha. Okay, so when you say they removed the open governance, does that mean like you and Zhao were no longer maintainers? Is that what that means?
Yes.
Okay.
Right. They moved from Redis. They're actually a little vague now. I'm not entirely clear what the system is, but they did dissolve the open governance, and they said so in their FAQ that, hey, this wasn't working, so we're going to do something else.
Yeah. Gotcha. Okay, so then how quickly did the fork come together and decided, hey, we're going to do some sort of fork? What was that timeline like?
So I think I have these dates right. So it happened on March 20th. We had basically decided we were going to fork on March 22nd. So then we had AWS, Google, Ericsson, I believe Alibaba on board at that time, as well as some other companies. But those are the four that had who eventually would have maintainer spots. Like Oracle was also kind of interested. Snap was interested, Verizon was interested. A lot of other companies who weren't directly contributing were also sort of like, hey, we'd like to help with this, right? We all have a vested interest in keeping the Redis project open. So at that point, we had also reached out to the Linux Foundation. So we had reached out. I'm a very big believer in having a foundation own the software to sort of prevent it from ever getting relicensed. There's some other strategies, like we could have used a more restrictive license or more a copyleft license like LGPL, which is another conversation that was going on at the time, to sort of make sure like we couldn't do this forking in the future or this like rug pull. But I'm a little bit less convinced of that. So we had engaged the Linux Foundation and they're like, yes, we will we're interested in that. So I think it was a week after that. So I think it was March 28th was the Thursday or Friday we announced it as being under the Linux Foundation. So there's about a little over a week. I believe it was 8 days from the announcement to when the actual creation of Valkey happened. Which it's funny. I think a lot of that time was actually coming up with a name.
Right.
I think we had gotten like all the stakeholders together in I think we had the stakeholders by like Monday, all kind of like signed off. But we had this name called Placeholder KV.
I remember that. Yeah.
And so we were still trying to. I wish that was more popular because I have like a bunch of stickers that say Placeholder KV, and
oh man, that would have been such a funny one.
Nobody knows what I'm talking about.
Yeah. That would have been a great long-term name for it. Interesting. And then when was oh man, I should have written this down, but when was like the 7.2. When was the first Valkey release?
I think I have a lot of dates in my head and I think they're all right. So April 16th was when we launched the fork. So that's when we were done with all the rebranding, have the containers all set up. And obviously it's a fork, right? We could have kept it a little bit leaner of a fork, but we also wanted to set ourselves up well for the future, to make sure we were able to, there's some stuff like within Lua scripts, there's like redis.call, which is like built in. We didn't want that to be kind of the de facto thing. So we added also server.call. And so you could use a more generic term as well. So there was some stuff like that. And then just a lot of rebranding just to make sure everything said Valkey instead of Redis.
Yep. And okay, so this is something that's happened a few times now. And the ones I think of like Mongo and like Elasticsearch being the one that seems like most directly on point, where there's already hosted services from a lot of different cloud providers. And that happened. I guess did it help to have that sort of prior art? Did you consult with these other teams like OpenSearch around how to approach a fork and deal with that?
What I think is interesting is actually we'd actually applied a lot of the prior art already, right? So a lot of what we learned from Elastic was that it's important to be involved in these communities, right? I had been deeply involved with Redis for almost 6 years at this point. And that was one of the things where hey, one of the common things, people push at AWS a lot is hey, you guys aren't contributing back. And so we're okay, we'll contribute back. We'll have people deeply invested in these projects. And so that when the actual relicensing happened, I was in the community. I knew all the key stakeholders. I had spent a lot of time so that we were able to get everyone together really quickly to sort of move fast in creating the fork, right? So I think that was the big thing that we learned. And I think that's the thing that, Amazon's a big company, but it's one of the few things I think Amazon's getting better at over time. We're trying to be more involved in open source.
Yep.
Actually,
I see that around. Yeah, that's absolutely true. So yeah, good stuff happening there. And now, of course, we have some new developments just in the last week now, exactly a week ago. Redis announces they're sort of back to an open source license, AGPL. I guess, does this change anything for you and Valkey, or how does that, how do you think about that?
Yeah, so it doesn't change too much of the direction of the project. So as I kind of mentioned earlier, there's 3 things that Redis changed back in 2024. They dissolved the open governance. The open governance was not reinstated sort of after this relicensing. They still have a CLA, so they're still able to, any project with a CLA, even if it's open source, they're still able to do a rug pull and go close source again later. But AGPL, it's a good license. It's an open source license. I'm happy that, it's good for the open source community to have Redis back under an open source license. So that's all great. But from Valkey's perspective, it's already been a year. We're so well established. The code has diverged as far as we know quite a bit. So, it's like trust has sort of been lost. So like nobody in the community really wants to go back and like remerge. Like a lot of people are like, are you going to merge back with Redis? I'm like, no, like a lot's diverged since then. And then also we have to have the conversation of moving from BSD to AGPL, which I don't think anybody really wants to do.
Yep. Yep. Is that the only way it could happen if you remerge? I don't know enough about licenses on how that stuff works. Like, would it have to be that license?
So there'd be basically two things. One is Redis could use its power in the fact that it has the CLA. It can relicense everything back to BSD, which I think they've said they're not going to do.
Yep. Okay.
The other thing was, yes, Valkey could. So Valkey's code's all under BSD. So BSD can be relicensed to be AGPL. So Redis can take any code that we've written, relicense it, and merge it. Right? We can't do the inverse. Right? We can't take AGPL, relicense it to BSD, and merge it. So it's kind of like a one-way, right? But Redis, the company, could do it.
Yeah. Gotcha. You said the code base is starting to diverge, and I want to get into improvements and stuff next. But like as of right now, is it still like 100% drop in from Redis to Valkey, where like, hey, some under the hood stuff has changed, but like the API is still pretty compatible? Or like, are there certain areas where it's like, hey, do you use this? Well, then you need to think about this change, or like where's compatibility between the two right now?
So the way Valkey's been framing our compatibility story is if you're using the set of APIs from Redis open source 7.2, right? That's where the fork point happened. We're still fully compatible at that point in time, right? Because that's sort of what we think is like, the real, core set of APIs. Redis has introduced some APIs since then. They've introduced a lot in 8.0, for example, which Valkey does not have compatibility with. So there's sort of like a superset of APIs that Redis has. Valkey also, it's like they're not overlapping supersets. Valkey also has some APIs we've built, and we have implemented some of Redis's functionality. So there is some amount of, if you're using this functionality, it might work and behave differently in Valkey. But if you're using these core APIs, they should all behave basically the same way.
Gotcha. So like the new whatever, like vector sets, I meant, yeah, not gonna be a Valkey. But yeah, a lot of the core stuff will still work. Okay, cool. Okay, so let's talk about improvements. Valkey coming out. You've had a 8.0 release. You recently had the 8.1 release. If I sort of look at it, like the things that stick out to me, and you can correct me if I'm wrong here, would be like the IO threads improvement, the new hash table stuff, which was 8.1, some replication stuff, a lot of like core sort of like performance and quality of life type stuff around that. I guess like let's start with the IO threads improvement, because like Redis is famously single threaded, which has some benefits, some trade-offs. We've seen some like sort of Redis compatible caches that are multi-threaded. Like, is this similar to that? Like where it's like, hey, now Redis is fully multi-threaded, or like what are these IO thread improvements? What do they add in Valkey?
Yeah. So I wanted to take a step back and talk about why we care about multi-threaded performance generally, and then how we sort of try to take that and apply that to what we built with IO threads. So if we're on like, most of these kind of caching that run sort of in cloud virtualized environments, if you have like a 8XL, or like let's talk about AWS. So if you're on like an R7G.8XL, you have, about like 100 gigabytes of RAM and a lot of extra cores. So if you're running in a caching environment, you're generally not using a lot of cores. Caching is a very efficient CPU type of workload. But it tends to be very much bottlenecked on the amount of memory you need. So you need a lot of memory and not a lot of CPU cores. So in that world, like it was fine that Redis was single threaded, because you would just have a lot of memory and it would work out fine. We've started to see somewhat of a change because we're seeing more kind of CPU intensive operations sort of start to take over workloads like vector similarity search are all much more CPU intensive operations. And so you might have kind of the same amount of data, but now you have, you're running on these boxes with a lot of extra cores, so it's good to utilize them. So like that's sort of the mindset. Like we still think command processing, like simple gets and sets are still really fast. And Valkey and Redis both have horizontal scaling, so you can have multiple processes. So just doubling the number of cores and doubling the throughput, you can just do that by scaling out. So we want to make sure that we're benefiting these more like search intensive workloads. And the other benefit is if you have like a single hotkey, having multiple threads be able to serve that one key reduces tail end latency. Because like if you have two, most latency kind of comes from contention, right? Commands are getting queued behind each other. So if you're able to drain that queue more quickly, you'll see lower tail latency. So, okay, so then the last point about that is with Valkey and Redis specifically, they have a replication process that does like a full sync. So usually you're basically have idle cores that are sitting around most of the time so that when you need to, you could do that fork operation, right? And so we have you often have cores kind of sitting around. So if you are a CPU bound workload, we want to be able to kind of burst into those cores. So to try to like piece all of that together, when you have systems like Garnet and Dragonfly are the two, and I guess Cache maybe to some extent, are these big other caching systems which are very thread scalable. They're targeting more the workloads of, I just have one box, I just want to run one box, and I just want to keep increasing the number of threads, like to not have to deal with any of the horizontal scaling. And so that's fine. Like I think they're kind of trying to solve a different use case. The way we're trying to think about IO threading is really about optimizing the price performance or the cost optimized performance of a single of a box, right? So we want to best utilize the cores we have available. So we don't want to degrade single threaded performance because most caching workloads kind of still run with that single thread performance, but we want to be able to kind of burst into these extra threads sort of as needed. And so I think it kind of helps to also add in why Elasticache specifically built this IO threading work. So IO threads had been available for a while within open source. I think you mentioned it was in no, I'm getting things mixed up. Someone else told me this morning that it was released in 2020.
Okay.
In that blog we both read.
Within Redis.
Yeah, within Redis.
There's IO thread. Because I know yes. Elasticache has this history of enhanced IO in 2019, TLS stuff in 2020. A lot of stuff that Elasticache has done. Yeah, anyway, go ahead.
Yeah. So one of the things we launched in Elasticache recently was the serverless feature. And one of the things the serverless needs to do is dynamically scale the amount of throughputs very quickly. So one thing that being able to quickly add cores does allows you to burst into spare capacity. So if you are over provisioned, you're able to kind of dynamically add cores, increase throughput, while at the same time horizontally scaling, right? Adding more shards to a cluster. So we added that so we could get that dynamic range, not because we care about how big of a number a single process can do, but so we can very dynamically adapt to performance. So that's a lot of context, which is sort of to say that I don't think just having a single process do a lot of requests per second isn't intrinsically beneficial, right? It's really, it needs to be benefiting the end users we have. So that sort of tries to add a lot of context about why we specifically try to not make, the main alternative implementation is why is Valkey not truly multi-threaded? Why is everything not multi-threading? That's because it has a lot of complexity and it's not solving these core issues.
Interesting. Okay. Interesting. And that's again, sort of beyond my expertise on that. So tell me about, I was going to ask you about Dragonfly later. Let's talk about it now. So
sure.
I guess there's a certain set of workloads where that happens to be better for, their approach is sort of better for. Is that what I'm understanding?
Yeah. If you have a box with 32 cores and you've paid for this box, right? Yeah. And you don't want to manage a cluster distribution, you could just start Dragonfly on it and it will pretty efficiently. It's a very thread scalable architecture. So when you add more threads, the throughput goes up. And I have lots of great documentation about why it works well. And they have a fully concurrent, I shouldn't say too authoritatively. I believe, I have not actually looked at their code because it's BSL, but I believe, and Roman can argue with me if I'm wrong.
Sure. Yep.
That it's a fully concurrent hash map, right? You can do concurrent operations. I believe they have a blog post. They are able to lock specific segments of the hash table. And so they're able to do parallel work on multiple different commands at the same time. And this also helps with latency as well. It brings down tail latency because commands don't get blocked. So yeah, it works well and scales pretty well.
Okay. Interesting.
Especially with CPU intensive operations, right? If they're doing multiple very expensive CPU, if they're doing the command in Valkey and Redis called like S-Union store, which like does merging of two sets, which is very CPU intensive. The fact that they can lock different parts of the hash map and then do that work together is good to help increase throughput.
Yep, gotcha. Okay, so then tell me about in 8.1 we have like these hash table improvements, and there's just really good blog posts on how that works. It talks about like Swiss tables and like all this, and also how you had to optimize that for Redis or like Valkey's unique needs. I guess like tell me about, first of all, before we even get into those improvements, how do these types of improvements even get on your radar? Like, do they start in industry first? Do they start in academia? Is it just like somebody's like, hey, I think there's some better way we can do this sort of thing? Like, what is the flow for these sorts of ideas?
So for the Swiss table, like the hash table improvement stuff, it definitely came from this like general knowledge that the hash table that existed before, well, so for everyone, so the way hash tables work is you have a key, you run a hash function on it, and that points to a bucket. And so when you have a hash collision, so two different keys point to the same bucket, you need a way to like resolve which of those two you want to do. So in the original implementation, we used a linked list. So we had two, we would just have them point one after the other. And that uses a lot of extra memory because a lot of overhead and having a dedicated allocation. So the common like wisdom sort of in the like 2010s was you should do what's called an open addressing type of hash table. So instead of having, you basically put the item in the wrong bucket, but that if you checked an item in the bucket and it's not the item, you basically keep checking until you find an empty bucket. So like that, these are open addressing type of tables. And so it's well known that these are more performant and more memory efficient on modern hardware. On older hardware, it didn't matter as much, but modern hardware is very good at prefetching and doing a lot of instructions in parallel. So although you're doing more work and sort of counterintuitive to like stick an item in the wrong bucket, like modern hardware handles this really well. So there was a paper and I guess like a video that was produced. So Google built this thing in 2018 where they talked about a lot called the Swiss table. And so a Swiss table is sort of like a very finely tuned version of this table. And so we had like known about it, we had seen it, but there's some very specific requirements that Valkey needed, and Redis needed. I guess this is in Redis timeframe, that made it kind of difficult to adapt this implementation to our implementation. Specifically, we have a way to have like a cursor, and you can like scan through all the items, and we provide very specific guarantees on how we scan over all the items, and we weren't able to preserve those in the Swiss table. So like you can go, there's an issue. I don't remember when it was open. It was open like 2021 or something. And we just started like just noodling on these ideas. And I think it wasn't until a conversation I had with another maintainer of Valkey named Victor. We were at an open source conference, and we'd kind of finally figured out kind of how to solve all these problems. And so we had like a good idea. And so, it just took a lot of time to figure out how to adapt sort of what was from academia into industry. I guess in this case, it was more from industry to industry. But yeah, we were finally able to adapt it. And, and we were able to kind of, I was kind of surprised. Like we knew it all in theory. We put it all together and it was, a couple percent faster. It was, saved like 16 bytes per object and all sort of worked well, which is nice. Like we launched in 8.1, which is about a month ago. And I was worried there would be like weird crashes or something, but everything, or like weird performance more importantly. But it's worked pretty well. It's worked kind of as expected.
Yep. How do you get confidence on like such a big change like that it's not going to have like weird performance stuff like that? Yeah.
Performance is hard. Like we were fairly sure about the functionality of it. We ran a lot of fuzzing. We have a lot of built-in integration testing. So we were pretty sure it wasn't going to crash. Performance is really hard to measure, especially because it's very use case dependent. Like we have no good typical examples of like use cases. Like we have some people who have like large objects inside Valkey, like 16 kilobytes. We have other people with lots of very small objects. And so we have a couple of workloads we ran, and like from what we could tell, the hash table was faster in all cases. So like that's a good signal that everything seems faster. And the theory is it should always be faster, right? Because we're doing fewer memory lookups. I guess I didn't talk about this when I was talking about the IO threading work, but like one of the things that sort of changed recently is if you actually do profiling on the IO threading that was in Redis before, is a lot of the bottleneck is actually on the CPU waiting for the memory access to DRAM, right? So when you go and like try to fetch that item, the CPU stalls. It's like, I need this from main memory, and you'll just sit there and wait for it to get sent over. So one of the things that we spend a lot of time doing is before actually executing the command, we do a bunch of stages to prefetch memory into the CPU caches so that when we actually execute the commands, we're not stalling on all this stuff. So it like increases the like actual command execution by like 2 or 3x, which only ends up being like a 2x performance overall improvement because that's it's Amdahl's law stuff. But one of the big things about this hash table is we remove one of the random memory accesses, right? Doing a common memory access, right? If you have some piece of memory that you're hitting a lot, it'll stay in the CPU cache. If it's kind of random, then it won't be in the CPU cache. You have to do the full miss. So we moved from 2 full misses to 1 full miss, which is a really big improvement.
Yep. Interesting. You mentioned you sort of tested it on some different workloads. Do you have like are those like internal AWS workloads that you know of that are like good test candidates, or other people, Alibaba and Google and different things like that? Or are they certain customers that are a little more, I don't want to say like adventurous on some of this stuff? Or like, how do you, before you actually release that out, get some of those tests, like real world tests?
Yeah, that's a good question. So AWS has some benchmarks that we use, and they're kind of based on data we've collected from the Elasticache fleet. And so we've made those available to the community as like testing grounds. We also have like a release candidate process, and we had a couple of folks actually go and run their benchmarks, against our system sort of before we did the GA, with the hopes that they would be able to tease out some of these performance issues if they were there. So it's not perfect, but those are sort of the 2 strategies we have as of right now.
Yeah, for sure. Do you have a bunch of like if you're making a change like this, even theoretically, sort of early on, do you have like a bunch of like micro benchmarks to like figure out, hey, is this thing faster, or is it more like theoretical where it's like, hey, we know we're going from 2 random misses to 1 random miss, and we know it's like going to be faster. We're pretty sure, and so like we can go pretty far with implementation before we can test some of that stuff, or like how are you testing even early on these different performance ideas?
Yeah. So ideally, there's probably like a 3-step process. The first is you should profile and actually see where the CPU is spending time. So stuff like perf can kind of tell you where in the code base you're spending time, right? So perf theoretically probes and unwinds the stack, and like this is where you are at this given point in time. So if you do that thousands of times, you know roughly where the application's spending a lot of its time. We also use like Intel has a performance counter that you can use. You can basically say, hey, every time you hit this point, increment a counter. So you can sort of build up, how much like actually like instruction level question. You can answer questions on like instruction level. How much time is this taking? Like how many DRAM misses are like L1 cache misses are you seeing? So we try to build up this like intuition first. Like, is this actually the bottleneck, right? Because like we can make something 100 times faster, but if it's not the bottleneck, doesn't matter. So once we have that, then we'll sort of isolate that code, and then we do micro benchmarks on that code, right? Say like, hey, how do we make this faster? But it's important to remember that just because it's faster in isolation doesn't mean it's faster in the whole system, right? So once we saw that intuition, we still need to do the final benchmark of everything stitched together and make sure it's actually faster. And then we kind of can cycle back to the first part and like reprofile it to make sure that, part of the code base is consuming less time than it did before. Because like there's this thing that's like still sort of vexing me is like if you actually go and check, so Valkey has this clustered mode, right? And one of the things it needs to do in this cluster mode is make sure like, is the request sent to me? Can I serve it, right? Am I the right node to be able to handle this? And it's like a pretty beefy chunk of time. It's like 5% of the CPU of command processing. And we go and profile it, and we saw this function is like taking 100% of the time. We're like, perfect, let's just fix this one function. We spent a bunch of time, we fixed it. And we benchmarked, like micro benchmarked, it was faster. But in the whole system, it was the same performance, didn't do anything. And just something else was taking up 5%. And we're like, what's going on? And it's because basically this 5% was shielding the fact that this other function still was going to this one function was pulling a bunch of memory into main memory. And now it wasn't doing that. But now this other part of the code base still had to wait on main memory to pull this memory in. So it actually didn't make the system faster. And we're like, well, and this other part was much harder to solve. And so we're like, I guess we're not fixing this today. So
We're at it. Yeah. How long does that whole process take of like, hey, identifying this thing, micro benchmarking, and then figuring out, oh man, it didn't work? Like, is that like, oh man, we just lost 2 months of work, or is that like something you can iterate through pretty quickly?
It's one of those things where if I'm not being randomized by meetings all day, you can do like a full loop in a day. You can have an idea, test it, loop it like in a day. But it's something that you need like a lot of focus on. So I feel like, we definitely don't lose months of effort, but it's definitely one of those things where you could do in a day if you want. And it's kind of fun, especially if it's like if you have like a good idea, a good theory. The worst thing is though, is like, you do it and there's no performance delta. And you're like, dang it.
Yep. Okay, so if I look at these like 8.0 and 8.1 releases, it seems like a bunch of, again, like good performance, reliability improvements in like a pretty quick amount of time, right? You've only been around for a year. Was there a lot of low-hanging fruit there? Was it an explicit decision to focus on like, hey, let's really nail the performance stuff that can distinguish us in certain ways? Or like, yeah, I guess what accounts for, or is this like about the pace that's happened every year with sort of Redis in the past and now Valkey?
I think we're able to innovate a little bit faster. I think a lot of these ideas existed. Like, not a lot of what we built in Valkey was like super novel. It's like things were coming out of the blue and we're like, this is a brand new idea. We had talked about a lot of these ideas with Redis. I think the Valkey project as a whole is set up in a way that it can move a little bit faster. I think for better or worse, like, so when we were in Redis, we had this open source team, this like 5-member team. And like, there was a time where like, we had a weekly meeting, right? And we'd like help sort of like for things that require like high bandwidth, right? When you're talking about IO threading improvements, it's good to just be in a meeting and talk it through. And so like there was times where we'd go like months without having a meeting just because the issue wasn't making progress. And one of the big things I wanted to change when moving to Valkey is like I wanted to make sure there was no bottlenecks, right? Like we wanted to make sure everything was still making progress, even if like someone was
like process bottlenecks, not like within Valkey, but like process bottlenecks around the project. Okay.
Yeah, process bottlenecks. Like we'd always just get hung up on stuff stalling because like we weren't making progress. So I think, and one of the big things we did change, because it's 6 companies and 6 different individuals. So stuff gets hung up a lot less, I think, just because the way the project sort of operates. So I think it's just that. I think it's just a lot more people. There's also a lot of excitement in a new project. Like a lot of people are excited to write code, make progress. So I think it's kind of those two things.
Yeah, cool. I also saw the release of like the Valkey Bloom module, and there's like this Valkey modules API. Are modules going to be a big focus going forward? Like, how are you balancing modules versus again like that core performance type stuff? Or again, is it multi-threaded enough? You have different people working on different things that you can sort of make progress on both pretty well.
Yeah, this kind of gets into this what I just said about like these process bottlenecks. Is we really wanted to be able to say, I took a lot of inspiration from how like Postgres operates. So PG Vector, I think, is a good example. If PG Vector started off as a separate project, and I believe the plan is to slowly move it into the core of Postgres, right? And so I like that idea of having this very rich, extensive API so that someone can go start a project with like a new data type. They can build it out, they can write all the code, and then it can sort of like, if it becomes super well adopted, it can then move into the main project. So JSON was one of those things that was actually donated by AWS. Like it was something we built a while ago. And it's nice that we built it within this module API framework. So we could just kind of take the code and didn't require a lot of modification. So there's like three modules to it, which are JSON, Bloom, and vector similarity search. So the goal is those are all available in a container. It's called Valkey extension. It's kind of in preview. That's one of the things like of the launches got kind of shoved down the most. Like people were interested in VSS, but didn't really care about how to get VSS, I guess. So like it's interesting. Yeah, you'd heard about Bloom, but like we haven't seen a lot of people actually using the container for it. Like a lot of people are interested, but I guess there's not a lot of adoption yet.
Yep. Interesting. What about in terms of, so I know like Redis has their own modules and those were sort of licensed separately. And I think they had a Bloom filter one or like a probabilistic one that had, and I imagine there's only so many ways to write a Bloom filter. Is that hard to like, I guess, write a Bloom filter without encroaching on their license? I don't know how licensing works in that particular area.
Well, first, yeah. Like this is.
You understand the question I'm asking there?
I mean, yeah. I'll first definitely say I'm not a lawyer. I don't.
Yeah, for sure. Yeah.
But like the way we think about it is that the API we can kind of emulate as needed, like decide what's useful, what's not, and then the underlying implementation, we just don't look at their code. We just build our own thing. In this case, I do know that theirs is written. Actually, I don't know this. I think it's in C++. It might be in C. I don't know that specific, but ours is written in Rust. So at least that level, we know the code looks different. But yeah, so just like from a project hygiene perspective, we don't look at their code. We look at, we might look at their docs, but we won't look at their actual code that they've written.
Yep. Interesting. Okay, you said that's written in Rust. Okay, what is Valkey written in? C?
Written in C.
Okay, but then modules can be written in Rust, or like parts of Valkey can be written in Rust, or how's that interop work?
So the way we've sort of structured it to right now is that the core project, Valkey itself, will be in C. And I guess technically we allow C++ for certain types of like surrounding libraries, but the main project needs to be in C. So one of the benefits of using modules is these modules can be built with a different, compiler, right? They could be in Rust, they can be in C++. Theoretically, they could be in Go. And that allows, if it makes more sense to write in Rust, we also have this like Rust SDK to make it very easy to write safe Rust code. I don't know how familiar you are with Rust.
I'm not. No, I just had another person on talking about Rust, and I was like, man, this is good stuff, but I can't ask good questions here. So yeah,
you should learn Rust. I love Rust so much.
I should. Do you? Good. Okay, that's what I hear about so many people. So yeah.
If you want it, so my slightly more nuanced take, even though this wasn't your question, system level programming. If you're working in a large team where there's varying levels of skill, Rust is very good at forcing everyone to write high quality code. Right. So I think a lot of organizations are like swooning over it because it's very good. Like you can take a college grad. It's very easy to learn Rust because there's so much documentation about it. And you don't have to worry about them like making mistakes about like memory safety or like leaking memory too much because it constrains big projects really well. So that's why I think a lot of people kind of like it. It does some syntax stuff I like. It does some stuff I don't like. And yeah, I think it's a good language.
Gotcha. Do you think most modules will be written in Rust going forward, or has it been the practice so far?
So right now we have three modules, right? So we have JSON, which is in C++. We have Bloom, which are in Rust. I don't think it matters too much which one of those, between those two, because like it's, to be blunt, like those two implementations are basically, we took a third-party implementation of the data type, and then we implemented the APIs on top of it, right? There's not a lot of logic there. The one that's more interesting is vector similarity search, which is like a searching engine. And a lot of that code is custom. And so that's in C++. I would have liked to see that in Rust for a couple reasons, especially around like the multi-threading memory safety stuff. But Google built it. They wrote in C++. We're not going to say no, rewrite your code in Rust. So, and if you're very methodical, like again, I'll go back to, if you're very methodical in writing C++ code, I don't think there's a lot of value in Rust. But from an open source project perspective, I think it has a lot of value to write in Rust.
Yep. How close are you to that, the vector search stuff? Like, have you stayed close to it? And I guess like how different are the requirements in something like Valkey, a memory-based system, as compared to PG Vector and Postgres, or Mongo's implementation and things like how different are those?
So I will talk a little bit out of my depth, but I have mostly ignored it until recently. So my understanding is in memory, vector similarity search is good for very high recall. So when you're basically descending a lot of the tree, right, to look for the best possible matches, because then you're doing a lot of random memory lookups, right? So you want to avoid as many disk-based lookups as possible, right? And so that's where Valkey can be more, I can do better throughput than something like OpenSearch or PG Vector. It sort of remains to be seen which use cases are that's most useful. Historically, Valkey is mostly used for very online applications, very real-time applications, right? You're serving caching traffic, someone's like on a website, someone's like looking for real-time, ticker values for the stock market. So when you're doing batch operations, it's a little bit less important to have this real-time stuff. So I think there's an open question of like where this makes sense. We've also seen an increasing push away from, so recall is only relevant if you're trying to do like approximate nearest neighbor. If you're just doing like you want the exact closest object, you can just flash search everything in the index. And so we're seeing a lot of people just stick indexes in Valkey as a key value string. They extract the string and then they do a flat search on it. So I think the space is rapidly evolving. And so it's very interesting to watch it evolve. And so I think what we're really just focusing on is providing good fundamentals, which is why, performance, efficiency, reliability, all that good stuff. And then, this is where it's nice to also work. Like I said, I work primarily on open source Valkey. It's really nice to also pay attention to what's going on in AWS, because I can at least be a little bit more tapped into like hear what people are talking about, what use cases they're missing, where do they need high performance stuff, and then we can try to use that to help inform where Valkey should be going.
Yeah, cool. Do you still like talk? Do you stay pretty close to customers? I imagine, and just like talking to customers all the time, like sort of standard AWS.
Yeah, literally right before this call, I was talking with a customer. I love talking with customers. It's my favorite thing.
Yeah. Oh, that's cool. Seriously, the best AWS engineers I know are just like that. Like they just like, learning info machines, just like want to suck it in all the time and figure out what people are having. For some of these performance improvements, are there trade-offs, or like does it ever happen where it's like, hey, this is better for 90% of customers, but this workload is slower? Does that ever happen, or is it mostly like, no, this is usually like pretty good across the board?
It's easy to build the stuff that's good across the board, for sure. I think it's a really good question because, I have this conversation a lot with our product managers where they're like someone was like, oh, we saw a performance degradation. And we're like, yeah, that's sort of expected. And I'm like, what do you mean? You told us it was faster. I'm like, well, it's complicated, right?
Not for every single person. Yeah.
Not for every single person. Like the most common thing. So the way our IO threading works, if you are not throughput bound, you are not going to see better performance. And under certain circumstances, if you're doing these operations we talked about earlier, like the S-Union store, you can actually see a little bit of degradation depending on your workload. So, those do exist, and we try hard to fix them and mitigate them. Like our goal is if we can make everyone better by 10%, that's better than making 1% of users better by 100% and everyone else worse by 1%. So there's a lot of trade-offs there.
Yeah.
Yeah, like we had.
Would you say? Oh, go ahead.
Yeah, I was just thinking because there's another example. There's this data structure in Valkey called hyperlog, which does approximate size of sets. And someone was like, I want to make this change. It will make, I think something like 14% faster, but it'll make it 2% more memory. It'll use 2% more memory. And we're like, I don't know how to quantify that distinction. And so we ended up not accepting it because we're like, I don't know if we don't know which of these trade-offs people prefer. And it's better to sort of keep it the same than to try to change it.
Yeah, yeah, very interesting. Would you say the Valkey project, I guess, like has a North Star, like performance is like sort of the North Star, or is that balance across adding more features, adding ease of use or different things? Like it is more of a balance of a few different things, or is like performance, hey, that's the thing we care about most?
So I don't think we have one thing we care about the most. There's been like five pillars we've talked about, which is performance, memory efficiency, reliability, observability, and ease of use, basically. We want to build features that make it easy to build applications on top of, right? And that's sort of like what JSON's for, right? Those are the vector similarity search stuff. So I wouldn't say any of those is more important than the other ones. We've sort of tried to not regress on one to build a feature in another unless it's like, observability is the big one. Observability is one of those things that like almost by definition has to impact performance. Because you're introspecting in the commands. So, we've made all the observability stuff all opt-in for the most part, because we don't want to regress on performance to give you observability, but people still also want observability. When your cache is having issues, you really want to know why it's having issues.
Yep, yep, for sure. Okay, I want to talk a little bit about these sort of like other caching options we talked about. We talked about Dragonfly a little bit, multi-threading. Yeah, I think you mentioned another multi-threading one.
Garnet.
Like Garnet, okay. And is that like a pretty similar approach there around?
No, Garnet's doing something completely different. I actually think Garnet's pretty cool. Garnet is a I sometimes a little mean. I say it's like, they think the problem with Redis is it wasn't written in C#. So it's a C# based implementation of no, it's actually much smarter than that. I'm being a little tongue in cheek. So it's like a full, some people also say this is reductive, but it's a concurrent hash map. So every operation is a lockless concurrent, right? So it's not taking so Dragonfly takes locks on like pieces of the data set. What Garnet does is it's able to like update stuff atomically using lockless algorithms. It's built on some previous research done by Microsoft, and it talks over the REST protocol. So it's really pretty cool. And they have some really impressive high performance numbers because they're not doing basically any locking, which can take a lot of time. So if you have very well-formed or uniform access patterns with a lot of keys, you could do a lot of requests per second with Garnet.
Interesting. Okay. And so that one is not like Redis compatible, but sort of serves similar workloads as Redis or Valkey. Is that what
No, it actually does the same Redis protocol.
it is? Okay.
It doesn't. It has some weird performance under edge cases, but if you're doing simple gets and sets, it's also fully open source, right? So I guess it's permissively open source. I think it's MIT.
Okay. Okay. What about KeyDB, which you mentioned? You mentioned Snap earlier. Snap picked up KeyDB. What was their sort of big insight there?
Yeah, so KeyDB was originally created as a multi-threaded fork of Redis. So as I said, actually, I don't think I talked about our IO threading architecture. So our IO threading architecture is we have a single command execution thread that delegates work to other threads. So the main thread will say like, hey, I need to go read from these 12 clients. You, IO thread, go read from these 12 clients. So there's still a main thread doing almost all of the work and coordination. So KeyDB did something slightly different. They had like a single global level lock. So they had threads that were context switching. Some of them were doing IO, and then they'd wait for the global lock to do command processing, and then they'd go back to doing IO. And so they have a slightly different multi-threading architecture, and ours is a little bit better, a little higher performance. But again, KeyDB built this implementation a long time ago, like 3 or 4 years ago. And so they iterated a bunch. So KeyDB was originally started as a separate project. It built a bunch of functionality like active-active replication, spilling data to disk. It was then later acquired by Snap. And Snap was sort of looking to... My understanding is Snap didn't really want to be in the maintaining an open source cache business. And so they were like, how do we merge this functionality together? So we've been working close with KeyDB engineers to get the functionality they want merged into Valkey.
Gotcha. And did you say Snap is like one of the sort of is part of Valkey? Yeah.
Yeah. It was one of the original companies that sort of backed Valkey.
Okay. Okay, nice. Tell me also about MemoryDB, which I think you said you worked on as well.
Yeah. So MemoryDB is just so it's basically Elasticache. So Elasticache is the managed Valkey service and Redis and Memcache, but MemoryDB has a slightly different replication system that makes all the data durably logged. So Elasticache just replicates to other replicas, keeps everything in memory. MemoryDB first pushes the data to a durable log. So when a MemoryDB node fails, you don't lose data. It just comes back up, has all the data. So it has nice stuff like it's consistent. You can really use it for like primary database workloads. So that's sort of the big thing about MemoryDB.
And so that's like, hey, I love the Redis API, and I'm willing to pay off or trade off a little bit of write latency, but and now I can use it as my primary database. Is it out there?
Mm-hmm. That's the pitch.
Nice. Okay. Yep. Very cool. Was that a fun one to work on?
I'll say yes.
Yes. Nice. Okay. One thing I meant to ask during the performance work section is Glide. So Glide is like this. Yeah. Okay. Glide is within Valkey, or is that an AWS project? I can't remember.
So it was started as an AWS project. So the key insight for Glide was that within the Redis ecosystem, a bunch of clients got built up incrementally over time, right? So there was like the Ruby space, they built a Ruby client, Python space, built a Python client. And they all sort of had different standards, different ways of doing like cluster topology discovery and, TLS and all this stuff. And so we had this, we see a lot of issues at scale within Elasticache. So we had customers who are like, hey, I have a 400 node cluster, and every time it does failovers, we see like it takes a really long time for our client to build the topology. And so, we looked into all these clients and like, well, we could fix them all individually, but instead, why don't we try to go build a single client that sort of has a Rust core. So we have the core implementation of Rust, and it's what talks to the servers. And so we can solve this logic once here. So that's like we call like the Glide core. And then we build high-level bindings that talk to this core. So instead of building all the complex logic in Python, we can build it just in Rust. And this is actually great for certain types of interpreted languages, which are pretty slow inherently. So all of the expensive, I/O work is done in Rust as opposed to in a higher level language. So we built that originally for Redis, just to sort of, it was with Native's project. And then when the licensing changed, we were like, oh, we can just donate this and make it a Valkey project. So now it's officially a Valkey like driver. It still works with Redis because it's, again, we're like compatible with Redis open source 7.2. So
yep, nice. How many language bindings do you have for Glide?
So we have 4 which are practically done. I think Go is not quite GA, but it's close. So we have Go, which is almost done, Java, which is done, Python, which is done, and no Java Python. I don't remember which one I missed. So those are done. We also have someone working on a C++ binding. We have someone working on a C# binding, and we have someone working on a Ruby binding. So a lot of those are kind of in progress.
Yeah, gotcha. When you talk to customers and they're having performance issues, are there a lot of things they can do? Like, is it like, oh man, your client is misbehaving in certain ways? Is it like, oh, you need to tune a few parameters on your server and that will work? Is it data modeling? Is it all of the above? Like, what do you see out there a lot?
I mean, it's definitely all of the above. We've had issues in clients, especially. There's a lot of very simple tuning you can do on a client to make it much more performant. There's things like, connection counts, pipelining, all that kind of stuff, which we sometimes see. We generally see the performance bottleneck to be on the server side, though. And so sometimes it's they're, using like a bad cluster sizing or topology, like they're using, if they could change like scale in and scale out, or scale down, like change the instance type and scale out can solve their problems. Oftentimes it's data modeling issues, especially when you're doing like cross-key operations. They're using very inefficient data types. Like a lot of the operations in Valkey are built in such a way that they should scale well, but there's some operations which are just like done it all, right? So we see a lot of people. I'm going to keep going back to this S union stuff because I talked about it. Like we see there's a customer that was doing this S union to basically say, I guess they're doing S difference. They're basically saying, like, hey, this is the set of objects a user had at point A or point time t, and then this is the one they had in time t2. Like, I want you to do a difference and tell me what the difference is. And that works unless the sets get very large, because it actually scales log n of the time it takes to do these differences. So that was one of those things where it's like, well, you know.
And what's very large in this case? Is that like 1,000? Is that like
Usually on the order of more millions, right? Because all this is done in memory. It's going to be fast.
Yeah, true.
And so we just sort of work with them to be like, instead of having one, have like 25 of these individual sets. And because like if you do a simple hashing, you can split the objects up, right? And also that also basically brings down the n log n part as well. So they're actually just overall producing a lot of CPU usage. So yeah, sort of across the board. It's very rarely tuning parameters. There's not a lot of tuning parameters in Valkey today. There are some, like, we have like different representations of data types. So this set I kind of have been talking about, you can either have just like basically an array of objects, because at some point if you're like, is an object in a set, it's actually faster to just have it all in a block of memory than it is to actually have efficient data structures. So and it's way more memory efficient. So when we transition from these dense encodings to these sparse encodings, is how we typically call it, we have like hard-coded values. So sometimes people tune those, but generally the defaults work.
It's kind of unique. It's not a big thing. Yep.
Yeah.
Okay. Yep. Sort of going forward on Valkey, if I'm like interested in Valkey and want to find out like, hey, what's getting focused on in 8.2 and sort of those things, is that like pretty easy for me to just like see, or is it like, hey, wait for the release candidate and you'll see what you get, or like what's that look like?
It's funny because like a lot of people come from the world like they want a roadmap, and so a lot of single vendor open source projects can have a roadmap because there's a product manager who's like, here's the roadmap. The problem with like vendor neutral open source projects is it's like, here's the things we'd like to build. Here are the things we think someone's going to build, but also someone could show up tomorrow and be like, I want to build this. And we're like, wow, that's so much better to build than what we had in our roadmap. Let's go work on that instead. So there's some stuff we know is going to come in Valkey 9. There's stuff like hash field expiration, being able to set a TTL in like a specific field within a hash. We're trying to fix, this might be too detailed, but like, so when we're doing like resharding of data, so in cluster, if you have multiple shards and you want to move data between them, right now it has to be driven entirely by a third-party observer. Like someone has to move all the data themselves. And we're trying to make it built in, so it like moves it between nodes directly, so it's much faster. So that will probably be there. We call that atomic slot migration. Because when it's third actor, the third actor can die, and then the server's just like, what's going on? Whereas in this new world, if the node dies, it just reverts and doesn't leave it in a broken state. So there's stuff like that. Full text search is also something we're building.
Will that be a module or will that be built in?
That's built in a module, yeah.
Okay.
Our goal is like very experimental features, module first, and then if they become super standard, we'll pull them into the core. That's the thinking.
Yep. You mentioned Valkey 9. When do you do major bumps versus minor bumps? Is that like time-based, or is that?
Right now, we've just been releasing every 6 months. The thinking is we'll do alternating major, minor, major, minor. We're in the awkward position, like we don't really do breaking changes. So we don't really need to do major bumps. But one of the things we learned about 8.1 is people were way more excited about 8 because it was a major version.
Yeah. Yeah, it's true. No one's excited about 7.14 or something like that. Yeah. So.
Yeah. So we're like, maybe we should just do major versions. I don't know.
Yeah. Yeah. Interesting.
But so I think having
I know it's hard. It's like, is it a marketing thing? Is it a, encoding some information about breaking changes like you're saying? Probably not. And that, yeah, so that's interesting.
You keep saying marketing, but like the way I view it is like you want to have the most impact. We want people to be using it. If that involves getting people doing marketing.
I don't mean it in like a derisive way, right? Like I think like getting that.
I know. I'm just saying it's
getting that information out, like the way that people consume it. Yeah, for sure.
I think especially in the engineering world, people are derisive about marketing, but
that's true. Yeah, you got to realize it's like part of part of the thing, right? About like, users of this have limited time and sort of paying attention to all these different projects. So it's like, how can you most efficiently just communicate to them like what's new? This is worth upgrading for, and those sorts of things like that. Yeah. So, is it hard to find good people to work on Valkey, like being so sort of low level and things like that, or do you feel like, hey, we have like a really good team, we have enough people going? Like, what's that look like?
We definitely have a lot of good people, but we definitely need more people. There's this split between like the big thing that we're missing is like maintainers on Valkey. We need more people like helping review this deep code, which is hard. Like that, I think that's a long-term problem with open source projects that are very like require a lot of tech depth to understand. Is like people come in, they're like, I have my one feature. I would like to build my one feature, and then they got their feature merged, and they're like, I'm good, and they leave. Which is fine. It's great. Like that's part of the process. But getting people to stick around for the long term, especially with something that's it's not super sexy. It's not, like it's so much easier to get maintainers on like, projects that are rapidly evolving and rapidly changing. And it's like, this is sort of like a lot's going on in the project, but it's all very incremental. So it doesn't feel as grand. Like we're not tripling the performance. We're,
10% a year, 5% there. Yeah. Things like that for sure.
10% a year. Well, that's why like iOS is super exciting because it's like this big number, but like, yeah, it's hard to have these big 3x improvements year over year, right?
Yeah, for sure. Yeah. Usually I ask people like how they're using AI in their day-to-day work. Like, are you able to use like any of the AI stuff for your day-to-day work, or is it so low level and specialized that it's hard to like, just pop in cursor and have it do stuff for you?
I'll give a concrete example. So yesterday I was debugging an issue in Valkey. So there's a data type called geospatial indexes, right? And so we had a customer who basically reported the fact that if I have a point and I want to find all of the points that are within a 0-meter radius of that point, and they had a valid use case, and I was like, this is weird, but whatever. It's like it should return that point.
What do they mean a 0-meter? What do they mean a 0? Like less than 1? But like what?
No, like literally 0, right? So technically, by the math,
it's like the point.
The point.
Okay.
Right. So there's a reasoning they're doing this, and so it should return itself, right? Because it's technically within the bounding area. On Intel, it was returning that point. On ARM, it was not returning that point. And so I was just like, well, this makes no sense. And so I went to my normal debugging, like I was using GDB, stepping through this, like the C code, and ARM was just behaving weird. And I was like, wow, what's going on? And so I had to go and actually look at the assembly instructions. So as I said at the very beginning, I know x86, so it's very easy for me to read x86, but ARM, I'm like, I don't know how these instructions do. But it's very nice because I would just give it to ChatGPT, and ChatGPT would just like translate everything for me in real time to be like, hey, this is what all these instructions do. And it made it very fast for me to read and figure out what was going on. And I mean, the reasoning is not that interesting. Like there was an instruction in ARM that just was having a rounding error, which it's allowed to do. It's not violating the spec. It's like Intel has this super fancy instruction that does like 2 multiplications and then like a subtract. Like it takes 2 numbers, multiplies them by something, and then subtracts them, which is exactly the operation that we were doing in the code. But ARM doesn't have that. So it was doing it in 2 steps, and that 2-step was introducing a little bit of rounding error. And because of that, it was putting it outside the zone. And so it was not returning it. So.
Oh my goodness. Interesting. So when you change that, do you have to, like, how do you even fix something like that? Do you have it run differently on ARM versus Intel, or do you just like abstract it a little higher level to where it works for both of them? It's not doing that.
In this case, I was actually very worried while debugging this that there would be like something, there was nothing to do. But in the reality, someone just like, a best practice when dealing with floating points is you should never compare something to 0. You should compare it to some extremely small value. And we weren't doing that. So in this case, we just changed it and to do some very extremely small value, and that fixed it.
Yeah. Okay. When you were having ChatGPT translate for you, did you have it translate to English or to x86 and say like, hey?
And to English in this case. I basically said, can you rewrite this to explain in English what each of these instructions are doing?
Yeah. Okay. That is definitely the most fun use of AI that I've heard. someone. So well done.
I like it for that. I'm not a big fan. I've been trying to get into like agentic stuff. Like I've been using the built-in stuff. For some reason, I get free GitHub Copilot. I apparently because I work on an open source project, but I'm the only Valkey maintainer that gets it. So I don't know how I'm on this secret group. So I do try to use it. But the agent stuff, I asked it to build reverse search into the Valkey CLI. So Valkey CLI is all in C. It kept writing the wrong thing. It kept just assuming, it seems to work well very tactically. It's like, hey, I want this very tactical function to do X. It's like, it's pretty good at that. But when you're like, hey, taking everything together, build this, it struggles a lot.
Yeah, for sure. Yeah, that's interesting.
Get there, I think.
Yeah, we'll see. Well, Madelyn, thanks for coming on. This is super interesting. I learned a ton. It was great to talk to you. Will you be at reInvent this year?
Hopefully not, but I probably will be.
Hopefully not. Yeah, nice. Well, I hope you're there. And yeah, it's been fun to see, Valkey's progress and all that stuff. So best of luck going forward. If people want to find out more about you, about Valkey, where should we send them?
Yeah, so you can go valkey.io is the best place. We have lots of blog posts on there. You can also, I'm pretty active on LinkedIn and Blue Sky these days, so presumably that handle will be posted somewhere.
Yep, cool. We can do that. Awesome. Well, thank you for coming on, Madelyn.
All right, sounds good. Yeah, thanks a lot for having me. Great chat.